lesson 3, doing X and Y-intercepts. Okay, X and Y-intercepts are exactly what they say they are. They're where they cross the X-axis, intercept it, the Y-axis, intercept it. Okay, so intercept means cross. So where they cross, that's what they're talking about. Okay, so it says a relation is a connection between two quantities. Relation can be represented graphically by a set of what? Ordered pairs. We talked about it yesterday. Yeah, strike one. The first component of a set of ordered pairs is the there we go. X coordinate. Values of the input are values independent. Good. Okay, second one's the Y, and then dependent. That was the main lesson. That's pretty much everything yesterday. Okay, in a nutshell. Plotting points and that kind of thing. It was adding on to it, but overall that was it.
What's that last word, dependent?
Yeah, dependent. Yeah, independent and dependent. Okay. All right, so let's look at this here. So for today, exploring X and Y-intercepts. So when we look at X and Y-intercepts, okay, so when we're investigating these, list the coordinates where each graph crosses the X-axis. So we're looking for where it crosses the X. Here, here, there, and there. Those are all X-intercepts. That's where it crosses the X-axis. So we're going to write those as ordered pairs. Okay, kind of getting all these started on this yesterday. Understand that X-intercept, so right here, where does it cross for the X? -1, -2, -3. So -3 goes here. Every time your intercept has to have what for Y? Has to have 0. It hasn't moved up or down at all. That's the point. That's why it's an intercept, because that's 0 for Y. Okay? So having 0 for Y, you can go ahead. If it says X-intercepts, I can do this for all of them. It has to be that. If it's Y is 2, it's not on the X-axis. Okay? So I look at graph 2. It's -2 and 3. Look at graph 3. It's -4 and 4. Those are my points for my X-intercepts. What do all the points have in common? 0 for Y. Okay. Okay, we're going to do the same thing for C, but we're going to do the Y-intercept. So we're going to be looking at these spots here, here, there, and there. All the spots where it crosses the Y-axis. Okay, let's move it up just a little bit. All right, so the graph 1 crosses the Y-axis at what? 0, 5. Graph 2 crosses, is it 6? Okay, thank you. Mine's cut off. And then graph 3 looks like it's 4, -4 again. And what do these have in common? X is 0, yeah. Okay, so the main concept you want to pick up from this, okay, listen. Main concept you want to pick up from this is to find the X-intercept, Y needs to be a 0. To find the Y-intercept, X needs to be 0. Okay? It's one thing you want to make sure you do because it's going to ask you to solve for these eventually. Okay, so X and Y-intercept of the graph. The X-intercept of the graph is the X coordinate of the ordered pair. The graph intersects the X-axis. Okay, the Y-intercept again is where it intersects the Y-axis. Given an equation of a graph, so you don't have a picture. If you're given an equation, so I just said, I'm going to say it again. To determine the X-intercept, you make Y 0. You might want to star this if you need to. To determine the Y-intercept, make X equals 0. And then you solve for that other variable. Okay, we'll do a couple of these in a second. Okay, the equation of a graph can be written in different form, all of which are equivalent. The equation of graph 1, so talking about above there, was 5/3 x plus 5, which can also be written in this form. All this is they got rid of fractions. Anybody know how they got rid of fractions? Anybody want to press me? Y equals 5/3 x. What's that? Correct. Times by the denominator. Okay, so what he's saying is this guy is equivalent, means equal, to these two. How that is what they did is they times everything by 3 to get rid of that 3 because it's a fraction. So if I times that by 3, that's a 3y. 3y. Times this by 3, it's just 5x now. That cancels. 5x. If I times that by 3, it's 15. Okay, so that's what he's talking about. Times by everything by the denominator to get rid of the fractions. Okay, so anyways, the equation of graph 1, previous page, we already have the answers, but we're going to do it algebraically now. So if I want to find the x-intercept, what do I make 0? Yeah, we just said 3 times. Y. We should all be saying that. Okay? Make y. Yeah, thank you. So you make y 0, and you solve for x. Conversely, for the y-intercept, you make x 0 and solve for x, or for y. You have to get that process in your head. That's the main process for this lesson. Okay, so I'm going to go and do it for you. I mean, 3 times 0, simple stuff. That's 0. Okay, grade 8, grade 9 algebra here. Minus 15. Minus 15. Divide by 5. X is negative 3, which is what we got, correct? Yeah, so negative 3. Y-intercept, that's gone, because that's 0. So 3y equals 15. Divide 3. Divide 3. Y is 5. X is negative 3. Y is negative 5. Now that is for the intercept. Just make sure you understand, we're not saying that the answer is negative 3 for all x's or anything weird. The x-intercept is negative 3. The y-intercept is 5. I'll write those as points. Remember, you just write it negative 3, 0, 0, 5. Any questions or concerns yet? Jose, how are you?
I'm good.
Good, great. Just want to make sure. Noah, good?
Yeah.
Yeah. All right, let's keep going then. Okay, so this one here. This is for the circle. Just so you guys know, x squared plus y squared makes a circle. You may not know that. Okay, you actually can put it in those TIA3s. You can make circle pictures because they'll make circles. I can show you how to do that later. What's that? Yeah, you can do a lot of pictures. There's like a TI-83 art little thing that people do. A little bit over the top, but it's there. Okay. All right, so here we go. X-intercept, y-intercept. So guys, the point is x squared plus y squared. That's very foreign to us. What I mean by foreign is very difficult. We're not used to that. Okay, those are higher level, higher exponents, right? But all I got to do is, if I want the x-intercept, what's the process? I make y 0. That's what everybody should be saying in here. So I'm just going to do this. X squared plus 0 squared, which is silly to write, but I'm going to write it just so you see that I'm making it 0. That's nothing. How do we get rid of squares? Square root. Now this sort of thing's going to get a little tricky for you. X is 4, but also negative 4. Why? Because 4 squared 16 and negative 4 16. So when you square root, okay, when you're doing these graphs, you want to think of the positive and the negative. Okay, so it's going to be 4 and negative 4 there. Write them both. 4 and negative 4. So if you're writing them both as points, Ollie, it's going to be 4, 0, negative 4, 0. The reason we have 2, if you go up to that picture, we had 2, right? That circle went through 2 spots on the x-axis. Okay, that's not very common. Okay, just letting you know, for general function, a circle is not very common, but we do need to get used to it for this. This is actually the same exact problem. It's going to be 0 squared plus y squared equals 16. We're going to have the same situation. Y is plus or minus 4. You can write plus or minus in one form like that. There you go. The reason they're all the same answer is because it's a circle. Okay, a circle is even all the way around, so it's going to go through every spot 4 away from the middle. Okay, so that's why that picture, it's 4, 4, 4, and 4. So when we go left and down, that's negative. Okay, we're almost done with this lesson already. Ridge?
Is that a 14?
Nope, it's plus or minus 4. Yeah, that's all right. No, they're talking about right here? Yeah, plus or minus 4 there. You can write it like I did here. It's fine. I just plus or minus is how you kind of write it in Math 20, so writing it like that now. Okay, last page, not page. Whoa. Okay. All right. Let's see here. All right, so let's look at this graph here. All right, so Lisa purchased a new car for $20,000. The value of the car can be represented by the formula 20,000 minus 1250t, where V is value and T is age of the car in years. So why is it a minus 1250? Why does that make logical sense? You lose value. It's losing value every year. So every year it's losing how much value? $1,250. Yeah, it's using $1,250 per year. Okay, so input 0, output would be the 20,000 because that's what it starts with. So this is a what? 0, 20,000. What does that represent? Is that an X-intercept or a Y-intercept? It's Y. We have a Y value. Okay, it's 20,000. That's the starting amount. Okay, so we put a dot here as 0. Okay. All right. Next one, put a 2 in. So what's the output? Well, 1250 times 2 is 2,500. So it's going to be 17,500. So we get 17,500 for a point. Are these ones down here, guys? Can you see it? Are they going by ones? Okay, so 2.
No, they're going by 5.
They're going by 5s?
No, they're going by 1.
The little things are
Oh,
going
never mind, never mind.
They're ones?
Yeah.
Okay.
Never mind.
All right, it's all right. It's good. So right here's the second point. Plug in 4. 4, I would... Yeah, 2,500, so it'd be 5,000, right? So 15,000, yep. Okay, so we go to 4, 15,000, so 4, 15,000 right here. And then 6 would be, what's that, 12,500? Okay, you can kind of see the linear relationship there. It says connect the points with a straight line and extend it. So let's try to do that here. Do the best you can. Use a ruler if you guys have one. I don't know how good I'm going to be here. Nope. Actually, I think I can cheat here. Okay. So roughly put that line in there. What does the ordered pair, guys, what's the ordered pair 0, 20,000 represent? That's the Y-intercept. Okay, so Y-intercept there. Also, you can call the starting price. Or starting value, excuse me. Yeah, starting value. You can put price, I guess, if you're selling it, but use the graph to estimate the T intercept. What does a T intercept represent? So we're talking about when it crosses down here. Estimate that for me. Somebody give me that's an estimate, so you won't be wrong. But what's the estimate for that intercept, and what does that mean? You think 20? Okay, so we'll say 20 years. 16? Okay, so we'll estimate 16. 16, 18, it's fine. We'll say 16. What does that mean? Attaboy. 16 years, it is worthless. Okay, your car has no value in 16 years. Yeah, some, but according to the linear chart, we're going to say none. Okay? Pretty much, yeah. You have to get. Sometimes that does happen. Your car gets so old that you have to pay to get it removed. Never? Okay. All right, just stay to the Colk and Wagon days. Use the graph. Stay with me. Use a graph to estimate the value of the car after 3 years. So what do we got? Somebody estimate that. What do you think, Andy, after 3 years? Okay. How about 10 years? What do you think, Hannah? What's the estimate on 10 years? So like right about where this would be, you just go up on this, because if you have your graph made, you should just go up from 10 and see right about where you're at when you hit the line. About 8,000? Okay, these are estimates, so it's okay. Okay, 14 years. What do you think, Lauren? What's your estimate for 14 years? $1,500? 4,500, okay. That's all right. It's an estimate. She's close. It's okay. Use the formula to verify. So if you use the formula to verify, the formula, remember, is 20,000 minus 1250 t. So we would just insert these for t, the years. So we just calculate that. So let's see how close we were. So 1250 times 3, 20,000 minus 1250 times 10, and then 20,000. What's that? Oh, for 2? Okay, sure. Just do the second one. Okay. So we're only doing 10? Okay. That works. What was it, the actual one for 10? 20,000 minus 1250, so that should have been 12,500. 7,500, huh? So it's close. 500 off, not bad. Okay, same thing. Use the graph to estimate when the car will be worth $5,000. So when will the car be $5,000? So you should go to this spot right here, draw a line over, and see what the time is. Okay, so how long will it be $5,000? Based on our observation here, it's going to be between 10 and 14 years. It's going to be between 10 and 14, based on what our estimate was. What do we think? 13? I'm going to say 13. Sorry, I'm going to go 13. It's all right. Half the purchase price. So half the purchase price is what? 10,000, which is in, you're saying 8 years, which we got right here. Okay, that was the estimate, even though we know the answer, but that's okay. Okay, use the formula to verify part 2. Part 2 was the same exact one here. Oh, what'd you say? Oh, you said 8 years. Thanks. It's a long time. 8 years. Sorry. So put 8 years in. So we're going to go 20,000 minus 8 times 1250, which that is 10,000. So that is half the purchase price. That's good. Complete the follow statement and describe the relation. The original value of the car is 20,000. It appreciates in value by 1250 per year and has no value after, what was the years again? 16 years? Okay, 16 years. All right. Okay, so that's all for this lesson already. We're done with that one. Okay, not yet. Okay, hold on real quick. We got to talk about these two things, just little definition words. So in this lesson, using algebra, we use the exact values for intercepts while using the graphs to estimate them. But here, we were asked to use graph values by interpolation, which means interpolation means that you can estimate within. Extrapolation means on the outside. We did talk about this last year a bit. Okay, so this process is called interpolation. You're estimating within your graph. If you estimate, when it was on the PAT, I remember, you can estimate on the outside of your graph that you don't have. That's extrapolation. Okay? Extrapolation, outside of what you have. Interpolation, estimating by the picture that you have. Okay, that's the difference between the two. All right, last thing here, I'll stop.